Okay, so today we are moving on with this chapter on planning, and we are right now going to discuss the schedule. Well, what we will do is, I suppose you people know a lot many things about the traditional project management. So, if you know something already, tell me as if I can move forward because we have a lot to cover and I don't
Mhm.
want to waste time. If you already know a concept, please tell me to move ahead, move forward, and probably we can save some time on that. So I'll just move on with the topic of schedule. After the scope has been established, now naturally we need to break down those work packages which we established in WBS, the breakdown structure. I told you yesterday that the smallest division of a WBS is called a work package, right? Although the work package can further be subdivided into activities, but from the point of view of the project manager who has to manage the WBS, he does not need to go down to the activity level. All the progress he needs to measure is at the work package level, right? Therefore, WBS is broken down to that level, not to the activity level. But naturally, if you want to calculate time and cost and resources, probably you need to break them down further into activity, and that is at the team level. Team sits down and breaks down the work packages into activities. That is called identifying the activities. Once all the activities have been identified, then it is comfortable for us to develop a estimate for the schedule, estimate for the cost, estimate for the resources. So these are the three kinds of estimates you need in your project: schedule, cost, and resources. As you understand, we have already talked about the scope. There is no estimation required in scope. Scope is established, the product scope and the project scope. And then we created the work breakdown structure. We also created a WBS dictionary. All of that was actually the scope baseline, the final version of scope. Now, if there is any change in the scope, we have to move a change request after the scope baseline has been created if we need to change anything in the scope, right? Now, because the scope has been finalized, we can now move forward. And the very first step after scope has been planned, scope baseline has been created, is schedule. And in schedule, we break down the work packages into activities, right? And this is the only job here. We are just to break down the activities into work packages into activities. Then, in the next step, we develop the sequence of those activities. The dependence, one activity may be dependent on other and things like that. So we develop a sequence, then we estimate each activity for the time purposes, how much time each activity is going to take. And then we put it all together in form of a schedule, do a critical path, critical chain analysis, critical path analysis, and a lot many things. Finally, when we come up with the final shape of the schedule, we uh, forward it to the authorities as if they can approve it. Once the schedule has been approved by the higher authority, after that schedule will also become a baseline, just like scope had become a baseline. So schedule will also become a baseline, and now we can't change anything in it until there is a change request and there is a approval. Explicit approval is required. Yes, what do you say? You said something, Padma?
No, sorry.
Okay, okay.
Yeah.
So understand how we go ahead with this. So the last step in planning for schedule is that we have to develop a schedule, right? And in the last step, it is baseline. Now, even schedule cannot change. Then we move on to the cost, and I'll talk about cost in the next in the after the schedule. So first, let's say what is the difference between the scheduling in a predictive project and an agile project. In a predictive project, naturally, as I said, work packages are broken down into required activities. Their dependencies and precedence relationships are determined. Then their durations are estimated based on the average resources. This may not be a really very exact calculation, but at least to the best of our knowledge, we do calculate the duration for each activity. We find a critical path and then we allocate resources to these activities as if they can be done. Ultimately, the schedule is compressed if required to meet any constraints, and then the schedule is baselined. In an agile project, because the things are very different in agile, we don't have to plan the whole project upfront. So the project team, which naturally is an agile team, they have time boxed cadences for their iterations. Iterations are of equal size, say 2 weeks, 2 weeks per iteration or something like that. And we will just plan one iteration at a time and we'll do it, and then we move on to the next iteration, and that way in every iteration we meet certain progress. We do have a continuous flow in those iterations, right? And interesting part is we only will be planning for one iteration, not the whole project. As far as the whole project is concerned, we did develop a outline roadmap, right? That is enough for us, right? And when we start an iteration, that is the time we break down our user stories into tasks, and then we plan what to do, how to do, what is the sequence, and all that. Although there is no need for explicit sequence diagramming and network diagramming and schedule, these concepts are not there in Agile. But anyways, if you like to use them in the most traditional way, if you still want to create a schedule for your Gantt chart, for your iteration, and you want to do those kinds of things, I don't stop you, but then it is not really an agile practice. In agile, we do things a little differently. But anyways, those people who are trying to do things in a hybrid manner probably will like to stick to the same procedures as we do in the predictive, even in their iterations. So I don't mind, but that is not the most efficient way of doing the agile. Anyways, so we adopt the release time frames, we plan each iteration with work, we prioritize, estimate, and decompose user stories into tasks. That is where the breakdown of the user stories is happening. And then we determine the iteration velocity. Iteration velocity is the how much work can you handle in one iteration as our team, right? So, for example, actually every story point is allocated, every user story is, when we estimate it here in planning, we allocate certain story points to each story, right? That's how we measure. For example, one story is 10 story points, another story is 5 story points, another story is 12 story points. So, whatever number of stories we complete, their story points, some of their story points would be considered your progress, right? And that would be, kind of determine your team velocity in an iteration. That means, for example, you did 55 story points. And when I say story points, it is not the user stories. This is every user story may have a different story point that depends upon the complexity of that story, difficulty level of that story, effort required in that story. So with that, we determine how many story points must be allocated to it. But anyways, if we say that we will do 60 story points in this iteration, but we end up doing only 55, then 55 is considered to be your team iteration velocity. But naturally, this cannot be perfect. In the next story, maybe we can perform better and we can reach the mark of 65 even. Our performance may not realize as such, so we may go down. So that the average of the iteration story points would be determined after every iteration, and that will say this is generally the speed by which the team can work in each iteration. We call it iteration velocity. The team works with the product owner to refine the backlog. You remember product backlog refinement we talked about. I said it is also called grooming, refinement, and a few other couple of terms can be used for that. So we will do the backlog grooming, our refinement of the backlog after every iteration. Before we can start the next iteration, we will reprioritize everything with the consent of the customer. Anyways, this was the difference between the two methods. And now we have the schedule management plan. The very first thing in planning, like in scope, the very first thing we did was to create a requirement management plan and a scope management plan, right? So remember that in predictive projects, the first thing you do for every knowledge area is to develop a management plan before you start. I also used to have this doubt that, okay, if the schedule management plan is developed in the first step, then what are we doing in the subsequent steps? What are we doing? Why are we identifying the activities? Why are we, sequencing them? Is it not part of the schedule management plan? What is your answer to that?
Well, the management plan gives us the way, determines how we're going to manage it, but then we still have to manage
Exactly.
the schedule.
Exactly. Schedule has yet not been planned, but we are just creating a guideline. How are we going to do each step? Like what are the rules for this project to identify the activities, to sequence the activities, to estimate the activities, and to create a schedule and things like that. So these all are the steps we have already outlined in the management plan. So schedule management plan is not the detailed plan, but a plan about the plan. We also call it a meta plan, right? A broad guideline. How are we going to go about doing the subsequent planning tasks, right? I hope you understand my point. So whenever I use the words management plan, you will understand that this is not the detailed plan. This is the guideline, principles, rules, standards, whatever you have adopted for this project to be used here. So you determine that in the schedule management plan. And another thing, I must tell you that schedule, whatever the management plan is, that is actually directly associated with and governed by the governance plan. There is a project management plan, there is a project governance plan. Governance plan, if you remember, I did mention governance earlier on. We talked about it in our first chapter. Governance is by the higher level management. What are their instructions? What are their guidelines for the project manager for development of his project management plan, right? So this is the broad guidelines under which project manager will establish his parameters, his limits, his boundaries, and he will remain within those boundaries. So those boundaries are drawn by the governance, right? And governance plan is actually to be your project management plan should be exactly according to the governance plan. I mean, it is within the limits described by the governance plan. And I am saying again, the governance plan is not created by the project manager, is followed by the project manager, and the project management plan, or for that matter, any other of the smaller subsidiary plans, must adhere to the project governance plan. Who creates the project governance plan? Must be the next higher level. Like project manager's boss is the project sponsor. So in that case, I would say project sponsor may be creating the governance plan for project governance plan. Or if it is a program manager on top of you, the program manager would be providing you the project governance. Or if it is a portfolio manager directly above you, then that person would be providing that. But anyways, that is definitely not the project manager himself or herself who creates that governance plan. Yes, project manager is responsible for developing the project management plan and all the subsidiary management plans, right? So they all fall under the project management plan, the scope management plan, the requirement management plan, the schedule management plan, cost management plan, quality management plan. There are 10 different areas. All the management plans are put together into the project management plan. Okay. Here, when we establish the schedule management plan, we identify that what is the scheduling method we are going to use in this project, what are the scheduling tools we'll be using, and naturally, these guidelines we are trying to follow from the governance plan, right? Governance plan does talk about a general guideline that these are the methods allowed in the project. These are the tools allowed in the project. You can use them, but there is a choice. You may have 2 or 3 methods available, or more than one tools available, which you are allowed to use. That is the governance plan. But in your management plan, you decide which method have you chosen out of the 3 options available to you. And similarly, which exact tools are you going to be using in this project, right? This is your management plan. And in this case, this is schedule management plan. Then you determine the schedule format, how the schedule will look like. Broadly, I'm not saying the final shape of the schedule, but how the schedule is generally going to look like. What is the format of the schedule? Establish criteria for developing and controlling the schedule. Now, this schedule management plan doesn't only talk about the planning, it also talks about how the schedule will be executed, how the schedule will be monitored and controlled, and ultimately till end of the project, how are we going to deal with the schedule. All the instructions are there in the schedule management plan, and these are the detailed instructions, not like the governance plan, which was an outline structure. And this schedule management plan, naturally, as we have been advocating, tailoring, that we can tailor it according to our needs. So project to project basis, you may decide how are you going to develop your schedule management plan. Defines the maintenance process for updating status and records project progress in the schedule model during execution. What all reports and returns are going to be produced during the process of schedule management or schedule planning or other thing, that also has been defined in the schedule management plan. Once the schedule management plan is complete, then we start the further work of actually identifying the activities, breaking them down, identifying, estimating, developing a schedule, critical path, critical change. Actually, those things will be planned after the schedule management plan has been created. Until the schedule baseline has been created, because with the creation of the schedule baseline, that means the approved final version of the schedule, which is executable, after that, we can enter into execution and start performing as per the plan. Okay. Here we have got certain components of the schedule. We have got project schedule model. That is the outline structure of the schedule, the format of the structure we had decided, and uh, we will adopt the specific scheduling methodologies and tools, as I said, for schedule development. And that is there in the schedule management plan. You remember, I did say that you will select out of the governance plan which method or tool are you going to be using, right? So that is your project schedule model. Accuracy, you determine in your schedule management plan that your calculations for scheduling, how realistic and how, how exact would that be? I mean, if you say this activity can be done in 10 days, then what is your tolerance about it? How much really can you give the allowance to this activity to get delayed or to be done early? For example, you said this activity, our estimate is 10 days. So when will it be too late? Will it be late if it is 1 hour late? No, probably not. No, we can accommodate that. We don't consider that a late. Okay, is 2 hours too late? So that means plus minus 2 hours. Well, that is also okay with us. Maybe up to 4 hours you can bear the delay or early finish of an activity, but not beyond that, right? So this is what I'm saying, acceptable range used to determine realistic activity duration estimates. And it may also include the risk contingency. So on any unknown thing which could happen to the project, any risk which can occur, we have to make allowance for that. We have to maybe keep some extra time in our planning. So that is called risk contingency as far as the time is concerned. So that will be inclusive of your calculations, right? So any duration you want to keep as a reserve, that will also be part of your acceptable range. Then how are you going to measure the schedule? Is it going to be in hours or days or weeks? You decide that in the schedule management plan. Your organizational procedure links, like, you create a work breakdown structure. And when I was explaining work breakdown structure, I said there could be a numbering system, like your project is 1.0 and your phases are 1.1, 1.2, 1.3, and so on. And that is why, because every work package should have a number of its own, right, in this hierarchy. And therefore, we can refer to that work package for accounting purposes. Those people who don't know what we are doing and how we are doing it, they are accounting or finance people, they will refer to those activities or work packages by their number, right? So the budget would be created according to the number, not according to the name of the activity, because those people may not be technical and they may not understand. So we will plan things and we will convey to them, the financial people, for approval. The numbers, those numbers are called organizational procedural links. Like, your work package is 1.2.5. The 1.2.5 might be constructing a wall, right? But the finance people, the accounting people would just know that this is activity number 1.2.5. Anyways, then we have got control thresholds. For monitoring the schedule, what is the limit of beyond which we will have to escalate the issue, right? Like we said, that we did put a limit to the level of accuracy. Similarly, while we are monitoring the schedule, how much delay tantamounts to escalation of issue. For example, if it is up to 4 hours of delay, we can deal with it in-house. But if this delay is beyond 4 hours, then the matter has to be escalated to the next higher level, as if they can give us the permission that we can take more time on this activity, right? So this is the control threshold. It may be expressed as a percentage deviation, that we have deviated this much from the baseline, right? So this is now the time that we should get a decision from the higher up how we are going to perform it. Then we establish certain rules, like we talked about earned value management. Little bit, do we talk about? Did you talk about the earned value? Yes, Fatma?
Yes, I think we talked about that one.
Okay. But anyways, it will come again, and I will talk more in detail about it. But if you understand the concept, you can even skip it. Kelvin, I was saying that because there's a lot of material, so in case you already know certain concepts, so you can tell me that all three of you are aware about this thing, and I may not explain it any further, right? So when
Okay.
I come to those things, we can probably do that and we can move faster.
Okay.
Great. Then reporting. What is going to be the frequency and format of various reports related to schedule? And ultimately, describe how schedule management processes are documented, recorded, right? So whatever has been done, is the critical path created, schedule has been developed. The last step would always be when the schedule is developed and approved, that is called the schedule baseline. Similarly, we had a scope baseline, and we are going to be having a cost baseline. These are the three basic baselines, which we call them the project objectives, meaning that a project objective cannot have been defined until we have some idea of scope, time, and cost. And these are the three baselines we will be creating, because all other knowledge areas, I said there are 10 different knowledge areas, but these three knowledge areas are more important because everything revolves around them. Everything else, all other knowledge areas, they do not have a baseline. We only have these three baselines. So they do not have a baseline because, for example, if there is a change in resources, if the resources are reduced or increased, that will impact the schedule, that will impact the cost, or that will impact the scope, right? So you understand what I'm saying here, that because everything which happens in the planning in all the 10 knowledge areas ultimately impacts either the scope or time or cost. Got it? That is why these are the three baselines. Got it? Okay, moving ahead. Start with benchmarks with historical data. Okay. I hope I did talk about benchmarking yesterday. Did I not? Okay. So you understand that whenever I say benchmarking, people have a kind of a twisted definition about it. Benchmarking is always comparing yourself with your competitors, right? As if you can kind of see where you are lacking and how much is a possibility of increase, right? How can you increase your performance? So, when we develop a schedule, a baseline, that also becomes your benchmark, because you will compare your progress always with what you have set as your baseline, right? We said that by the end of this month, we would have completed 20 jobs, 20 activities. But actually, we could not complete 20. We just completed 20. Sorry, we did not complete 20. We just completed 15, right? So our progress is we are lacking behind by 5 activities. I am just saying that by number of activities, but that is not a very good way of measuring because some activities are long, some are short, some are complex, some are easy. So we can't really just count how many activities we have done. We actually have to see how much time have been spent on those activities or how much money has been spent on those activities. That is the schedule baseline and the cost baseline we have to refer back to. Anyways, then we have got the historical data. That is the data available with us from the earlier projects we have done. We always will refer back to that data whenever we are doing something. In a hybrid project, as you understand, we are partially predictive and partially adaptive, agile. So maybe our top level plan is just like I just described, that we have a project management plan, we plan everything, we do the scheduling and all. But naturally, because it is a hybrid project, everything cannot be as clear as a predictive project. Therefore, we could only have planned up to a certain level, beyond which we don't have any knowledge, and agile teams would be planning the details in their respective iterations. And as far as the agile is concerned, I have already told you, in agile, we plan iteration by iteration. When we start an iteration, we plan that iteration, we do that iteration, we deliver that iteration, and then we move on to the next and next and next. In predictive schedule planning, as I have already described, project manager breaks down the work packages into activities, dependencies, precedences, sequences, estimates each one of those activities and their resources, determine a critical path, resolves any conflicts of over allocation of the resources and all, and compresses the schedule, which I have already described to you, right? So this is what a project manager does in schedule planning. We have already been introduced to the work breakdown structure. Again, I'm showing this to you, but actually work breakdown structure should exist as if these work packages, which are at the lowest level of the WBS, can be further broken down into activities. And interestingly, the number of the activity would be inherited from the work package concerned. For example, if this was the work package which I am breaking, so it has got 4 activities under this work package. So I would number them. 1.1.1.1 is my first activity. 1.1.1.2 is my second activity till we reach 4. So similarly, this work package, which has already a larger number, will have the activity as 1.1.2.1.1, right? And then 0.2, 0.3, 0.4. That's how we are going to break down the work packages. Dependencies, the sequence of the activities when we have a dependency that this job cannot be done until and unless another job has been completed. For example, you can't construct a wall until the foundations have been completed. Agree with me? Such a requirement, which is not possible, that until the foundations are complete, you can't start the wall. That is a mandatory requirement. That is something which is in the nature of the work, that it cannot be done in any other way, right? But there could be dependencies which could be discretionary in nature. For example, project manager, for better management of his project, he plans certain stop points that, okay, although we could have done these 2 activities together, but for better management, he does not allow the team to start working on the second activity unless another activity is done. It is not a mandatory requirement, but just for better management, project manager himself established a rule of sequence between two activities. This is called a discretionary requirement, and this discretionary requirement is definitely within the control of the project manager. He can remove the discretion, he can bring the discretion in, but these activities are to be respected, whatever the status is. Then there could be requirements, there could be certain restrictions which could be imposed by external sources, maybe the enterprise environmental factors, outside world, climate, and weather, things like that. And there could be internal dependencies which could be, enforced from within the project or the organization. Right? Now, they could exist in a unique combination. There could be mandatory requirements which are external, and there could be mandatory requirements which are internal. There could be discretionary requirements which are external, and there could be discretionary requirements which are internal. So these are the four combinations we can have: external mandatory and external discretionary, internal mandatory and internal discretion. So these are all the types of dependencies you can have within a project. So far, so good. Okay, this is how the dependency does exist in a precedence relationship. Precedence diagram is a way of representing the relationship or dependencies amongst various activities. Okay, let me clarify one thing. Two activities may have a dependency relationship, right? For example, this first activity, which is confirm key stakeholders and customer attendance, is a prerequisite for doing the next activity, which is erect signage with customer branding. So first, the stakeholders, key stakeholders and customer attendance must have been confirmed. Only after that, you can start erecting signage with customer branding, right? So the arrow between these two activities shows the direction of flow. The activity on which the subsequent activity is dependent on is called a predecessor activity. And successor activity is the one which is the dependent activity. Alexandra, are you getting it? Okay, good. That means the direction of arrow shows from where the arrow originated, where the tail of the arrow is touching the box of activity, which is the predecessor activity. Where the head is hitting which activity, that is the successor activity. So successor activities are always dependent. They are always driven. And predecessor activities are always the drivers. They push the buck, right? So these two activities can have only one-way relationship. One activity has to be dependent on other, right? And it is very much possible that there are two activities in the project which have no relationship, so there will be no arrow between them. There is no dependency between them, right? But in a predictive project, all the activities have some dependency, except for the very first activity of the project, which is not dependent on any other activity. And the very last activity of the project, after which there is no activity. So with the exception of the first and last activities, every activity has a predecessor and every activity has a successor. Are you with me? If you understand this, are you aware about network diagramming and critical path? Kelvin, do you do that?
Yeah, I'm familiar with this.
Okay. And what about you, Fatma? Mike.
Yes, we do that.
Okay, very good. And Alexandra, do you have an idea?
Yes.
Very good. So probably I should not explain things to that extent. If you have any doubt, if you want me to explain something and you do not have a fair idea about it, I will explain. But otherwise, I'll just skip these minor details, right? Okay. Now in this slide, you can see there are generally from this diagram, we have assumed that predecessor is always before and successor is always after, right? But that is not actually the case. This is one kind of relationship. There could be 4 types of relationships. Now, look at it very closely. As in this diagram, you see there is a start point of every activity and there is a finish point of every activity. Got it? So this line, the starting line of the box, left edge of the box, is the starting edge, and the right edge of the box is the finishing edge, right? So every activity has a starting edge and a finishing edge. If the arrow is being originated from the finishing edge of the predecessor and enters into the starting edge of the subsequent successor activity, this relationship is called finish to start. Finish to start. And that is the most common relationship in your project. Maybe you create the whole project based on this philosophy, right? But I must tell you, this is not the only philosophy for linking two activities. There could be a start-to-start relationship, meaning an arrow being originated from the predecessor activity, from the start of the predecessor activity, and enters into the start of successor activity. What does that mean? Okay, let me get back to the finish to start. What does the finish to start mean? Activity A should have finished as if activity E could be started, right? That is how I will define a finish to start relationship, that the predecessor activity must have finished as if the successor activity, in this case is E, could be started. Are you with me? That is easy, right? That is easy to understand. But when we enter into the next relationship, for example, let's talk about the start to start. It says activity C, which is a predecessor, should have started as if I can start the successor activity, which is activity F. Is it understandable? That means I don't have to wait for activity C to finish to start activity, the successor activity, but I can start anytime after the activity C has been started. Activity F can be started immediately alongside the C activity or any time later. It does not mean that C and F are always going to be parallel or they can always start together. That means that F can start as soon as C has started. But you see, it is perfectly all right if F started 10 days later than the start of C, it still is a start-to-start relationship. Kelvin, you comfortable with the idea? Yes, Kelvin.
I am.
Do you know that you use this kind of relationship?
Yeah, start.
Okay. Now, if you understand this, then you can interpret the finish-to-finish relationship as well. Kelvin, can you try it out? Can you try to explain how finish-to-finish works regarding activity D and activity E?
Yeah, both activities basically needs to finish at the same time.
No. That is
No.
exactly what I explained in the start-to-start, that it start-to-start doesn't mean that C and F activities will have to start together. No. They can
Yeah,
start together,
there's activity needs to
but
finish for the other one to meet the final, step.
exactly. So,
Yeah.
in a way, I'm trying to say that activity D should have finished as if
To
the
complete.
activity E can be finished. That
Yeah.
means, yes, there is one possibility that D and E can finish together, but that is only one possibility. Other possibilities are E could finish any time after the D has finished. Got it?
Sorry, can you repeat the last one?
Activity E, which is a successor activity, it could finish any time after activity D has finished. It
Right.
cannot finish earlier than the finish of D. It can
Yep.
finish with D. It can finish after D, anytime after D. Got it? But that would be a wrong interpretation that this finish to finish means that D and E are finishing together. No, not at all. Yes, partially you are right. Yeah, it is one possibility that D and E could finish together, but E cannot finish earlier than the end of the D. It can finish later, but not earlier than the finish of D. Similarly, start to start, C and F could start together. That is one possibility. But F is not allowed to start before C has started, right? So F can start with C or after the start of the C. Anytime after. Can you wrap your brain around these two concepts? Start to
Yeah.
start and finish to finish?
Yes.
Okay, now even if Alexandra, are you comfortable with this? Fatma?
Yes, I am.
Okay. Now I'm going to introduce you to the fourth type, which will confuse even if you are very well conversant with these ideas. Now it says predecessor activity, which is activity D, should have started as if the activity F, which is the successor, can be finished. Now wrap your head around it and try to explain what does it mean. Fatma, your turn.
It means the task F cannot cannot finish until the task E is started.
Yes, exactly. This is slightly curvy because we could somehow wrap our head around the start to start and finish to finish. But here there is a basic confusion. We have assumed that predecessor is always happening first and successor is always following it, right? And that was a wrong assumption. That could be true in the case of finish to start, but as we have seen in start to start and finish to finish, that it is not really, we are not waiting for the end of one activity as if the next can start. That could only be true in finish to start. So there is a possibility of parallelism which could have been seen in start to start and finish to finish, and that makes sense as well. But this start to finish does not really make any sense at all, because predecessor in this case might be happening after the successor has been finished. You understand my point? I mean, activity D may not have finished when the activity F has been finished. Right? Okay, now is the time for a little example. Right? Forget about whatever we just discussed. I will give you two activities, one predecessor and one successor. You will tell me explain the relationship. Foundation of the building, that is one activity. Construction of the foundation of the building, and construction of the walls. Right? These are two activities. And classically speaking, they are finished to start. Until and unless the work on the foundation is completed, the construction of wall cannot be initiated. Generally, that is the understanding. And that is the most sane understanding we could ever have. That is the most practical explanation of two activities, predecessor being the first and successor being the later, right? So that fits into the big picture very easily. So far, so good. Now, each one of you, I'll give you a problem to solve. Convert this relationship, which is finished to start, between the foundation and the wall. First, Alexandra, I'll come to you. Can you convert this relationship into a start to start? Is it possible?
No, that would mean that the foundation and the walls, well, yes, you could start the foundation in one part, and then as that's being completed, you could start the walls in that part. They don't have to be, it doesn't have to be, I don't know enough about construction, to be quite honest, but
Okay.
the theory here is that they don't have to start at the same time. They just have to start one after the other at the very least.
Yes, exactly. So that means the work on foundation should have started as if the construction of wall could be initiated. So it could be initiated any time after that. But the earliest you could start the wall is as soon as the foundation has started, which is tricky, but that is what it says. Start to start. One possibility is that as soon as the foundation is started, the wall can also start. Right? Now, there might be a gap between these 2 points. So we say, okay, for example, if there is a curing time required for the foundation to settle down, maybe it is a 24 hours curing time, then after 24 hours, we can start the construction of wall while the foundation work is going on. Maybe foundation work is 10 days long. So after 2 days, we could have started activity F. We could have started the construction of walls on the areas which have been cured, which have been settled. If you don't understand this problem, give me an example from your own discipline or area. You deal with software or what? Alexandra?
It really changes, but yeah, we can say software for now.
Okay. So if it is a software, maybe you have to complete the coding and then you can start the development of the software. What do you got? No,
I can
okay.
start working on one part while I'm also working on another part,
On
but the other
other
part has to have started
Right,
first.
right.
Yeah,
Okay.
I understand.
That is exactly what the start to start means. Now, Fatma, finish to finish for you. Same example, foundation and wall.
Okay, finish to finish.
Finish.
definitely the wall cannot be started until the foundation is not finished.
Okay, in finish to finish, there is no mention of
Sorry,
anything
yeah,
starting.
sorry. Like, both of the task,
No, there is a predecessor
sorry,
and there is a successor. There is not
yeah,
one of the tasks. One is predecessor, one is successor. On the activity on which you are dependent, right? That is the
Okay,
predecessor. Yep.
yeah, the wall construction cannot finish until
Until
foundation is not
has
finished.
good.
Yeah.
Or you can say the foundation work should have finished as if we can finish the work on the wall,
Mm-hmm.
right? So you got it. Does it make sense to you? Is it all right?
Yeah. Only the question is that, like, in which project methods we are using these ones, because
All kinds of
naturally,
all
yeah,
kinds of projects can use these relationships. All four relationships can be used, but I'll explain to you. As I've already said, more than 95% of the times you would be using the finish to start relationship.
yeah, this is like,
Okay. So when to use
what
the
I was,
start to start, finish to finish, that is when you are uh, too tied up. You can't meet the schedule in the conventional manner, and you may have to squeeze the things, and you may have to introduce some kind of parallelism into the project, as if the project end date could be squeezed in, right? So that would be where you will try to find, okay, which two relationships between the predecessor and successor could be changed from finish to start to maybe start to start or finish to finish. That is exactly what we are trying. We are trying to compress the schedule. So only in those areas, either there is a mandatory requirement that these things can be done start to start or finish to finish, or we are trying to compress the whole schedule, and whichever activities could accommodate the start to start or finish to finish relationship, we will change them to that. As far as the start to finish relationship is concerned, that is really curvy. Kelvin, it is your relationship. So can you explain how can you do that? Foundation
Okay,
and wall.
wall and foundation will be, yeah, activity D will be the wall construction, and
No,
activity F will
no,
be
no,
the
no, no,
foundation. No?
no. Arrow is originating from activity D. So activity D is the predecessor.
Wall and foundation, we're talking, correct?
Activity D is the foundation, right? Activity D is the foundation.
Yes.
Why? It is because
No, I'm saying activity D is the wall and activity F is the foundation. So the wall can
no, no,
start,
no,
but
no,
only can be,
no, no.
yeah?
You see, activity D is the foundation. Activity F is the wall, but the relationship has changed. We are saying that work on foundation should have started as if the work on wall could be completed. I know it doesn't make sense, but this is how this relationship is. This is the most difficult relationship you can imagine. Most of the people cannot use it, cannot even understand it. Therefore, PMI recommends that finish to start relationship is a mandatory relationship. Start to start and finish to finish relationships are considered optional when needed. And start to finish relationship may be avoided. Why avoided? Because you may understand the logic of it, but you can't really explain it to everyone. Others may not understand it, and there might be confusion, and ultimately there may be disaster. Either you make sure that whatever is your understanding, everyone is equally for everyone it is equally understandable. But as Kelvin you just described, you switched these two activities just because it doesn't fit the script, right? How can it be possible that the predecessor activity should have started as if the successor activity could be finished, meaning the successor activity is finishing after the start of the D, meaning activity F might have started even before activity D has started, right? That is tricky.
Yeah.
That is tricky. But I'll give you some examples on that. Okay, for example, there is a guard on a night shift, on a graveyard shift, and his duty is from 6 p.m. to 6 a.m., right? And then the next guard will come at 6 a.m. and he will work till 6 p.m. So let us say one is guard A and one is guard B, right? Now, the condition is that the first guard cannot leave his duty until the next guard has arrived and taken the charge of that duty. Let me call who is depending on whom? The first guard is depending on the second, or second is depending on the first. The night guard is depending on the morning guard, or the morning guard is depending on the night guard.
The night guard depends on the morning one.
Yeah.
Night guard is depending on the arrival of the morning guard. Therefore, the morning guard is the predecessor, and the night guard is the successor. Although the morning guard came later, but because the night guard cannot leave his duty. This condition is until the new guard takes charge, you can't leave. If he doesn't come by 6 a.m., he comes at 8 a.m., you will keep doing your duty until 8 o'clock. He just can't leave this position. Got it? And you still wrote wall here. Why?
Sorry, I thought that you didn't see that.
It is not the wall. It is the foundation. You still can't wrap your head around it, huh?
Yeah. I'm
Okay.
thinking that I have used the start finish and thinking about the wall and foundation. Yeah,
Let's talk about it. Let's talk about it.
Like a D is for me the wall and the F is the foundation. I don't know. I still have it.
No.
Okay.
You are trying to explain the finish to start relationship. That is a traditional finish to start relationship. You see, in this relationship, start to finish, the arrow is originating from here and going here. This is the predecessor, this is the successor. Got it?
Okay.
So foundation is still the predecessor. But the condition has changed. As soon as the work on foundation has started, we could have, finished the work on wall, which looks impossible. I know it looks impossible. You can't wrap your head around it. But okay, let me get back to a classical finish to start relationship. Tell me, it makes sense. When the whole foundation has been completed, only then you can start work on the foundation, on the wall, right? That is very, very comfortable, very easy to understand. There is no complication in that. So anytime after the foundation is completed, we can start the work on wall. That is absolutely okay with us, right? Okay, let us convert this relationship to start. Tell me, how is it possible that as soon as the work on foundation starts, the work on wall can also start? Like, Alexandra gave the example, and I stand by that. That is okay with me. There is a possibility that I can somehow, maybe with a little gap, but I can do these two things simultaneously. But C is the predecessor, the foundation is the predecessor. The work on foundation should have started. Now, from the engineering point of view, Kelvin, you are the best guy for that. You tell me, from engineering point of view, how that is possible, start to start, how the wall construction can start while the foundation has yet not been completed.
Not start in parallel, but at least you may have a portion of the foundation and you can start building the wall in that area and carry
Okay.
on. But
BL,
I mean, it depends
uh-huh.
on the wall. It depends on the foundation. So yeah,
Okay, got it. It depends. Be creative. You are an engineer. You be creative and
yeah.
come up with some solution on that. How can we?
Adding the curing time, so you pour the foundation, you leave it cure, and then you start building the
Okay.
wall on that one. So adding a lag on the
Okay.
planning.
Let me tell you, why don't you use the quick set cement? Rather than waiting for 24 hours, you may have to wait for just 1 or 2 hours,
Okay, depends on the concrete
right?
technique that you're using as well. So
Okay. Yes, you have to come up with creative ideas. And naturally, this is not really something new I'm telling you. That thing is existing. Quick set cement does exist. Somebody thought of it. Somebody invented it. They are using it, right? That was to address this problem, right? Okay. Okay. If you understand that, uh, any other solution for that? How can I start working on walls when foundation is yet not complete? Any other solution? Anyone out of you? Naturally, Kelvin can be the give the best answer, but maybe you people are creative enough to come up with some ideas.
I'm an electrical engineer.
Okay, but you
No,
live with
zero.
engineers. You live with engineers. You
Yeah.
people are more logical, right? Fatma, what do you think?
Um, Honestly, no idea.
Alexandra,
Which was the question?
uh, how can we start the work on wall while the foundation is yet not complete?
That's what we've already been talking about, isn't it? We can start the work on the wall
Uh-huh.
while this foundation is still in progress.
Yeah, I accepted that. That was one solution. Then we also came up with another solution that was let us try to reduce the curing time. That was the second solution. I'm asking you some other idea, out of the box
Recast,
idea.
recast, something like this. I don't know.
Exactly. That is what I was. That is also existing. Precast is also existing. You are constructing walls elsewhere, then you transport them as soon as the foundation starts getting, cured. You just start installing the walls while the foundation is being constructed, right?
Lego.
Yeah,
Yeah.
just like a Lego. Exactly, that is possible. But why did it not come to your mind as in the beginning? Why your mind was single track on the basic assumption that foundation must complete as if the wall can be started? Because that is the most obvious solution, and our mind hooks to the easiest solution first. You can't think of more complicated situation. But when I try to pose that problem, when you are in a problem situation, you will come up with unique solutions, and those unique solutions are because of creativity, and they result in innovation. So I'm not saying that these relationships are to be used very commonly in your project, but sometimes when you really are stuck, when you have problems like doing the project earlier, or maybe you are already delayed and you want to meet the finish date with in the remaining project, you may have to squeeze some of the activities. Like, if A activity, foundation, was 5 days long and wall construction was 8 days long, so that will classically speak from the critical path method, 8 plus 5. 13 days it will take. But if your boss says you just have 10 days to complete these activities, what you do? Naturally, finish to start relationship cannot do it. That takes 13 days. So that could be made possible by any of the subsequent methods. Start to start can do that. Finish to finish can do even better. And start to finish can do wonders. Although this is usually not understandable by most of the people, but still start to finish can do wonders, really. Got it? I leave you with this thought. This is something, do a little bit of brainstorming on it on your own. Try to experiment on it, think about it for a while. Although I do understand, I do agree that most of the time, most of the project managers may never have faced these scenarios except for the finish to start. Right? But as a good project manager, you must understand at least you may have to use start to start or finish to finish in some situations. And for a very technical kind of a environment where everybody is educated enough and can understand, probably yes, you can use start to finish relationship, but generally because all the people are not equally intelligent, maybe you understand what you say, but your team who is actually going to work on it, they are totally confused. They can't wrap their head around the idea and they will not be able to do it. Therefore, we suggest that start to finish relationship should be avoided as much as possible. Right? So, directly jumping to start to finish, how is it possible that as soon as the foundation work has started, the walls should have been constructed? This is the most difficult situation what I am referring to. The foundation has just started, but walls has been constructed. How can that be possible? If you say precast, that is not a solution because walls will have to be erected on the foundation. So the start to finish doesn't do that. Walls are already done and dusted. They have gone home. As soon as the foundation was started, they have gone home. The wall people, they have done their job and they've gone home. While the foundation work is going on and on and on. How is it? Think of a way.
Can you say again your question, please?
I say, think of a way that walls, the completion of walls could materialize as soon as the foundation gets started. As soon as the foundation gets started, the walls could be completed. You were constructing the walls, maybe precast, maybe whatever. You were doing that beforehand. But as soon as the foundation, you started digging for foundation, the walls could be declared complete. While the foundation work will go on.
Making me thinking out of the box.
Too much out of the box. Too much.
Crazy.
Let me give you a hypothetical situation. Have you seen, what do you call that, garden umbrella?
No.
You have got a umbrella in your lawn under which you have chairs and everything lying there, right? So you want to construct that, right? You want to construct that facility, and I want you to apply start to finish on that. There are no walls. Naturally, there is a one umbrella which is on a fixed point. So the umbrella is already ready. We bought it from the market, and as soon as the area is earmarked to me that this is where this thing is to be installed, I will, as soon as they dig a hole for me, I'll put the umbrella there. My my wall work is complete. My successor activity is complete. But then I will keep doing the foundation work, like, I will have bricks installed and cemented around it and make a sitting area and all that. And benches can be placed on that later and all that. But the umbrella has been installed. The wall structure has been installed already as soon as I had a hole to put my umbrella in. Does it make sense?
Sorry, Suhail, but you are saying that we have to think about a way which is not normal.
It is not normal. Yep.
Okay. It's out of logical order, right?
It is, yeah, of course it is. By the way, start to start and finish to finish are also creative. They are also not really very logical, but this is absolutely out of the box. Absolutely. Start to finish is absolutely out of the box.
And can we do like in parallel planning, like doing both of them at the same time, starting both of them at the same time, and then even we can, yeah. Can it be a
Well,
solution?
can you refine that idea a bit, because I like it. You are thinking in a creative way, but let us make sense of it.
Okay, like we can start for instance pre-assembling certain part of wall, and then while we are like completing the foundation, I mean that the wall can be partially prepared in advance and then quickly assembled in the side, like when the foundation is ready to um dig out, or like pull the all or to install all the pre-assembled walls.
I would say as a very good example could be just like the word Kelvin has spoken, the Lego set. Like, the construction you are trying to do is like, Legos. Every, say, Chinese have constructed a hotel and they did it in a couple of days. There's a multi-story hotel and they did it in couple of days, only I think 10 days or something like that. And interesting part was, it was a completely agile concept. From the very first day, they started with the foundation, the lowest floors, and there had to be a hotel. By the end of first day, the hotel was fully functional. As soon as they placed all the rooms and all the halls together, I mean, they were pre-constructed. They just put them together in a Lego kind of a condition, and it was operational. The hotel was operational, right? Although it didn't have the first floor or second floor, nothing was there. Next day there was a first floor installed, and next day the third. And as soon as those floors are being installed, they are being populated. They are being brought to use.
Yeah, I have got the same idea while they were like building or constructing hospitals during COVID.
Yeah, exactly. This was in COVID they did that, but that was not even in days, that was in hours. They had constructed a hospital of, I don't know
I got the
how
same
many
idea
beds.
because I was hearing that they are working in parallel, like they are pre-assembling the walls and everything, and then like they are building and cover it up. So
It was a height of efficiency. Things were so well coordinated that in couple of hours they had, I don't know how many, 300 beds or 1,000 beds, I don't know, but that was that many beds of hospital constructed in a couple of hours. Simply
Yeah. And it was
astonishing.
like, it was like something I'm thinking out of the box, and it was
It was
totally out of logic order
out
of
of logic, yes,
engineering. Yeah.
yes. And then most interesting part is you could relate it with agile. You could relate it with agile. The requirements are changing. Maybe right now the requirement is 300 bed, but by the end of the day, or maybe, because it is COVID and number of patients coming is increasing day by day, and our projections say that we will end up having 1,000 patients. So on the run, they are changing the design and they are extending it to that limit. So it is a kind of an agile project as well. So where there is more creativity to be used, where the certainty is not there, a lot of risk is there. Probably those are the situations we like to go agile, right? So that makes a strong case for that, because in agile we have all creativity working. Anyways, okay, let's here have the concept of lead and lag. You understand the four types of relationship: finish to start, finish to finish, and finish to start. I know you still might be a little confused, but by your interaction, I do understand that you had some grasp on the idea, a little bit of grasp. Now you're not totally confused. Okay, now let me introduce you to another concept, that is lead and lag. Kelvin, can you make a guess what these are?
It's the kind of delay that we can implement to some activities, as a predecessor.
All right. So we have these four kinds of relationship. There are, for example, this is finish to start. I say activity E can start 4 days after activity A has finished. That is a condition. For example, after activity A, we may have to give it a rest for 4 days, or maybe curing time for 4 days, as if the activity E can start, the next activity can start. So that is called what? Lead or lag?
That's a lag.
That is a lag. Everybody understands that. If there is a gap, a requirement of a gap between two activities, that gap is called a lag. So we say, we will write it like Fs plus 4. Fs plus 4 means the activity E cannot start until 4 days has passed after activity A has finished. The relationship, you can write it here, Fs plus 4. Rather than Fs, write Fs plus 4. Got it, Alexandra? Now, lead is other way around. That is, activity E can start 2 days earlier than activity A is scheduled to finish. That is shown as a negative sign. That would be Fs minus 2. Fs minus 2 between A and E would be that E can start 2 days before the finish date of activity A. Right? It still remains the finish to start, but we have given it a lead time, lead time of 2 days. So lead time is what? Lead time is overlap of 2 days between two activities, and this overlap is our saving in time. If these two activities, 8 days and 5 days and 8 days, were taking 13 days, and if I give an overlap of 2 days, it will reduce to 11 days. So without changing the relationship, just by increasing the lead time, I can compress the schedule, if that is possible. If that is not possible, then go and try out the start to start or finish to finish. That will help you a lot. That will achieve that goal. But I would once again say, finish to start is the traditional way of doing anything. Okay, lead and lag is done. Okay, let's move on. For each and every activity, A, B, C, D, whatever the activity is, every activity has to be estimated for duration, for cost, and for resources. In scheduling, we are more concerned about duration. So, activity duration estimate is a quantitative assessment of the likely number of time periods required to complete an activity. I think that is self-explanatory how much time this activity will take. Now, when we will be doing the cost estimate, we will say how much money this activity would need to complete. And when it comes to resource estimation, that is another knowledge area, we will say how many resources are required to do this activity, right? So there are three types of estimates. Right now, we are only concerned about the duration estimate because we are talking about scheduling. Elapsed time. What is the concept of elapsed time? How much time has passed, right? I hope you understand that. How much time has passed from the start date, right? There is an activity which had a starting point on 1st of October and the finish date is supposed to be 15th of November, right? So, actual calendar time required for an activity from start to finish is basically the elapsed time. We need 45 days to complete this activity, right? When this time will elapse, the activity should have been completed. Got it? Effort. That is the number of labor units required to complete a scheduled activity, or WBS component, often expressed in hours, days, or weeks. Right? So same we can do for the duration as we do for the resources, as we do for cost. So we can do it for duration. Like you see, when we are estimating the resources for an activity or for that matter time for an activity, duration for an activity, it depends upon the number of labor we have. If one person can construct a wall in 100 days, how many people will be required to complete this wall in 50 days? Very simple question.
Can you repeat?
Can you say again, please?
I'll repeat the question. If one person can construct a wall in 100 days, how many people will be required to construct it in 50 days?
In how many days, you say?
No, how many people will be required to construct
Yes.
the wall in 50 days?
50.
50 days.
0.
0?
0.5.
Think again. One person can do it in 100 days.
Yes.
Two people can do it in
50 days.
Okay, 2 people in 50 days. Yeah, that's what you're saying.
That's exactly what I was asking.
Yeah.
Okay. 4 people will be able to do it in 25 days, right? Got it? But have you heard about law of diminishing results? Law of diminishing returns. This is just not a simple calculation. If you keep increasing the resources up to a certain level, the performance will keep increasing. The duration will keep reducing. But after that, there will be no improvement any further. Like, okay, let me give you another example. There is a wall of 10 feet long and maybe 8 feet high. You have to construct it, and you think that this wall can be constructed in 10 days by one person. Got it? What if I put 10 people on this wall? Can it be constructed in one day? Am I confusing you guys?
No, it can't be constructed in one day because that's like because for instance, like the foundation needs to set, there's other things that are time intensive that are required.
That is beside the point. That has been done. If one person can do it in 10 days, the only wall, I'm not talking about the foundation. Foundation is not being discussed here. One person can do it in 10 days, 10 people can do it in one day, correct or not?
And yes, they can.
They can?
Yes, they can.
Okay, let
If
me make it more difficult for you. I have placed 100 people on the wall, 10 feet wall, 100 people on the wall. How much time will they take to complete it? It is not a simple calculation. The answer should be 1/10th of a day. In 1/10th of a day, 100 people should be able to construct the wall. Right or not?
There are some constraints that.
Exactly. That is what I am referring to. There are constraints.
Oh yeah, it's like if one woman can get birth a baby in 9 months, so 9 women may,
Okay.
that's the
Exactly.
metaphor.
That is exactly the point. The thing is, the total working space is 10 feet. How many people can work there efficiently? Let's calculate that. Tell me how much space a person will require for construction of the wall. Minimum space in which he can do efficiently, he can use efficiently. How many people? How many feet of wall could be reserved to one person? Your guess?
Depends on the size of these people.
Yeah.
3 people, right? So
Yeah.
if I put one person, yes, he can do it. If I put 2 persons, they can do better. They can do early. If I put 3 persons, the efficiency is increasing. The time is reducing. But as soon as I put the 4th person in, the working space will reduce, and their arms will clash with other person, and ultimately they won't be able to perform well. So the law of diminishing return says that after a certain limit, the performance starts going down until there is a point when there is a complete standstill. 100% standing on a wall which is 10 feet long, they can't even stand there. How can anyone work there? I hope you understand my point. So this is not a simple calculation. There is a law of diminishing return. Diminishing return, what we calculated here, not more than 3 people can work efficiently. As soon as the 4th person is introduced, the performance will reduce. 5th person further reduce. And there will be a point, maybe when there are 10 people there, the work cannot happen at all. What to talk about 100 people or 200 people or 1,000 people? No, they can't do no wonders. I hope you get my point. Everybody?
Yes.
Okay, good. So here are some of the estimation techniques you could have done, and it is from the predictive project estimation techniques. The agile techniques are slightly different. Okay, we use these techniques. One is called analogous. Analogous is taking an analogy from our previous experience. Okay, I have done a similar job in a previous project, and it was quite similar to what we are doing here. So if we could do it in 3 days in that setting, Probably we can do it in 3 days in this setting as well. That is an analogy I have created with a previous experience. Does it make sense? This kind of estimation is called analogous estimation. And interestingly, that doesn't mean that if it was done in 3 days in the previous project, we also estimate it to be 3 days. Maybe we have a kind of a relationship established that, okay, this work is doubly difficult and the previous work was easy. This is doubly difficult, and therefore we spent 3 days there. So let us put 6 days for this job here. This is also analogy, right? Or we could say it took 6 days in the previous project. This is an easier project, and here it may take 3 days. So it could be same 3 to 3 days, or maybe it could be a higher figure or a lower figure, right? Analogy is just a ratio, an assumption. But this is not a very good method because this is not accurate. The next method is parametric. We establish a certain parameter that, okay, this much work can be done in 1 hour. How much work can be done in 10 hours? Got it? So, for example, this is duration we are talking about. So, let's say, I think that is the same example which Kelvin was trying to give, but I will try to explain it in another term. Let's talk in terms of money, right? So, I say that construction generally cost, if you are doing construction generally cost, say, $400 per square foot. That is the average rate of a specific kind of construction. So it doesn't matter how big the project is, I will charge $400 per square foot. So I have established a parameter and I will calculate if it is a 3,000 square feet building, I will multiply 3,000 by 400 and that would be my total estimate for the construction of that building. So based on a parameter, this method is better than analogous because that was analogous was kind of only based on historic data and no real data. But parametric is a kind of statistical method where we have taken some kind of a standard average and we are using that as a parameter, and this is more workable. Does it make sense?
It's pretty commonly used in construction.
Yep. Exactly. Do you understand, Alexandra, what I'm saying? Okay, then there is a very statistical method, and that is called 3-point estimate. And this is where we want to be much more precise in face of uncertainty. How can we be precise in face of uncertainty when we don't know things? That could be, I just do not base my opinion on my personal experience or experience of 2 other people. I say, let us do a survey and ask many people, what do they think this job can be done in how much time? So I collect maybe from 100 people, I have got 100 responses. I do the statistical analysis. I create a bell chart. You understand what is a bell chart? Bell diagram. That is the basic calculation on a basic statistical analysis is based on that. So that bell curve will actually determine the frequency of responses against, you know, we have got 100 responses. We will group them into, like, majority of the people are saying this, and then the next level of majority is saying this, and then the minimalist people are saying this. Now, there is a range on the positive side and the negative side. For example, the average of everything is 10 days. Everybody says approximately 10 days. I say, okay, but how many people are saying between 8 and 12 days? There are about 60 people who are saying between 8 and 12 days. So there is a high likelihood that actual time would be between 8 and 12. But there are people who are saying that between 6 and 10, 8 to 10, between 6 and 12 days. And I mean, let's deduct those 8 to 10 people, but we are entering into the next bracket where the middle bracket is no more. So people who are saying from 6 to 8 days, or who are saying from 10 to 12 days, they are in the second category, and probably they are kind of about 30% of the people or 35% of the people. And remaining 5% of the people would be those who would be saying between 2 days to 6 days, and from 12 days to maybe 20 days. So this is a third category. So highly likely are those people who are in the middle bracket, which is called one deviation, single deviation. +1 -1 deviation is the single deviation, majority of the people of this opinion. Then the second majority, the second layer is the second deviation, and the third layer is the third deviation. What we do is, in our statistical analysis, we take the minimum and the maximum value. There is a person who says this job can be done in 2 days. There is a person who says this job can be done in 20 days. They might have their reasoning. I cannot ignore them. Normally, people would say, why don't you go with the majority? They are saying between 8 and 10 days. So just take their opinion, and based on that, you calculate how much time it will take. But no. Tell me why a person thinks this job can be done in 2 days. Normally, 60% of the people saying this can be done in 8 to 10 days. But there is one person who says it can be done in 2 days. Why? Is he wrong?
Yeah, no freaking idea what had to be done.
Okay. Actually, this is the person who claims that he has experience doing similar kind of job, and he was able to do it in 2 days. Whereas majority of the people says that they can do it in 8 to 10 days. Why this person has this kind of experience? Number one, this person might have been lucky enough. He might have got all the right moves to make at that point in time. He was having a lot of opportunities, and therefore everything fell into place, and he could complete it in 2 days. On the other hand, the person who is saying it cannot be done in less than 20 days, in his experience, he is also right. Probably he was unlucky guy who faced a lot many negative risks, and everything was broke, everything caused a problem, and that job could hardly be done in 20 days. So he thinks it cannot be done in less than 20 days. Both are right.
I've seen that the optimistic is kind of the
2 days.
person that is in charge of making sure the things are done on time.
Mhm.
But he put additional pressure on the team by just cutting some of the duration, just for
okay.
the sake of, putting the team some under pressure.
Right.
And the pessimistic on the other end is the guy that is so conservative on the duration. So he's always putting, he knows that work can be done
External.
in 10
Yeah.
days, but he's adding another, safety factor for
Mm-hmm.
being conservative just in case that, not getting in bad
Okay.
shape as soon as the project gets a little bit delayed.
If you put it that way, I agree with you. But you see, actually, this is the time when we are doing a survey. So they don't have any stakes in it. They are just sharing their experiences. So as such, they are not having that kind of stake. So I would say whatever they're saying, they're right in their own, opinion. Let us take their opinion. Uh, I mean to say, uh, although this job can be done in 8 to 10 days, but in worst cases, there is a possibility that it could extend to 20 days, and best possibility it could be done in 2 days. So I will take the minimal value and the maximum value as well as the opinion of the middle brackets, and ultimately I'll try to do a weighted average. Weighted average, why? Because the majority of the people who are of the opinion that it can be done in 8 to 10 days must be respected more than others. Agreed? So the middle value will have a higher weightage, and we will give one weightage to the optimist and one weightage to the pessimist. So we have got 6 values: pessimist, optimist, and 4 in the middle. Agreed? Agreed or not?
Yes.
Okay. So uh, that means when we will take the average, I'll say my estimate of time would be, my 3-point estimate is optimist plus 4 times the most likely value plus the optimist value. Optimist plus 4 times plus the most likely and plus the pessimist value. Divided by 6. I am taking an average of 6 values, right? Divided by 6. That is a 3-point estimate. If the data set is good enough, kind of about 50 to 100 people have given the opinion, we will use this formula. Otherwise, if the data set is small, then probably we can't apply this formula. In that case, we will take a simple average. Simple average of 3 values, that is optimist plus most likely plus pessimist divided by 3. Got it? Probably
Yes.
I'll be showing you these calculations in the subsequent slides. And then there is a bottom-up estimation. This is the detailed estimation which the project manager does to the nuts and bolts. He calculates everything. No, there is no approximation. There is no statistics here. We say that, this activity will actually, after a lot many calculations, we found that this activity will take 12 days, and this activity will take 8 days. This activity will take. This is the exact calculation. We calculate every activity's duration and then sum it all up to find the overall duration of the project. So far, so good. These are the 4 estimating techniques, and these techniques apply not only to duration, but when you are doing the cost estimation, again, we can use the same 4 techniques. When we are doing the resource estimation, we can still use all these 4 techniques. Agree with me?
Yeah, I have used the 3-point to assess all the project risk that we have. So it's a matter to ponder the impact on any risk that we have, either on the project budget or in the program. So the 3-point is the technique that we're using. But to build the program, the main program, basically what we use the parametric technique.
Exactly. I do understand. Because the larger the thing is, more it is impossible to go bottom up. Bottom up will be under your program, your project manager's activities may be bottom up calculation, but your calculations at the program level would be something like parametric or 3-point or something like that.
Yes.
Okay, good enough. So this is what I was talking about. Your estimate would be optimist plus most likely plus pessimist divided by 3. That would be when the sample set is small. That would be called a triangular distribution. And what would that look like? Let me draw it for you. A triangular distribution is if this is a continuum and these are the number of people, then the negative opinion to the most likely to the positive opinion, it is just like a triangle. These are the most of the people, majority of the people are here. One person is here, the pessimist. One person is here, the optimist. But say their majority is just 3 people, 1 plus 1 plus 1. There are total 5 people who have given the opinion. So because the data set is too small, I will not be using the beta distribution. I would be using the triangular distribution, and simple average formula will be used. If the opinions were 3, 5, and 10, then it will be simply divided by 3, and 6 weeks would be taken as our estimated time. But if sample set is very precisely calculated from maybe 50 or 100 people, then I will multiply the middle value, and that in that case, the beta distribution will look something up like a bell curve, in which this is the highest point, this is the highest number of people. And actually what is happening is both sides of the center are divided into 3 parts. That means this is the 0 point, center point. This is plus 1, plus 2, and plus 3. This is minus 1, minus 2, and minus 3. And you can see this goes up like this. This goes up like this. This goes up like this. This, and this. Now, these are 6 deviations. Remember that. 3 deviations to the positive side and 3 deviations to the negative side. So how many deviations are there? 6 deviations. And that is why we are having 6 here. And the people from here to here, that is from -2 to +2, this is called the most likely. 4 deviations are allocated to them. 1 deviation is allocated to the pessimist. 1 deviation is allocated to the optimist. So there are a total of 6 deviations. 1 plus 4 plus 1 divided by 6. So this is called a bell curve. Both of these methods are statistical in nature, but this is more precise and this is more preferred. Beta distribution is more preferred. And what is the size of R deviation in a beta? What is the size of R deviation? That is calculated by this. PERT, standard deviation, is equal to pessimist minus optimist divided by 6. So for example, the highest value I had got was 20, and the lowest value I got was 2. So this is 20 minus 2 divided by 6. This is my deviation. Deviation is how much? That is 18 by 6. 3. No, sorry, I'm wrong. 18. Yeah, 3. You're right. 3 is the right answer. That means each deviation is approximately equal to 3 points. 3, 3, 3, 3, 3, and 3. So how much is that? 3 into 6, 18. That is the difference between the maximum and the minimum. Did you get it? Okay, let us get back. Okay, this is called the critical path. If you're doing a predictive project, it doesn't happen in agile. We don't have a critical path in agile projects. In predictive projects, every activity has to be connected in the network. Every activity has a predecessor and a successor, except for the first activity doesn't have a predecessor and the last activity doesn't have a successor. But every other activity, for this activity, this is the predecessor and this is the successor. Let me highlight that if I can. I don't know how to do it. Okay, let me try to do it in another way. Can you see that red point?
Yes, I can see.
Okay. So, what is the predecessor of A? Sorry, activity 2. 1, this is the predecessor of activity 2. And what is the successor of activity 2? 4 is the successor of. So, in this case, as I said, majority of the project, in normal projects, majority of the activities are linked by finish to start. So, interestingly, all of these activities are finish to start. There is no start to start, no finish to finish. Generally, this is the case, right? So 2 has got 1 as predecessor and 4 as successor. 4 has got 2 as predecessor and 6 as successor, and so on. Now, if I ask you who are the successors of activity 1, then you will just look at how many arrows are going out of 1. So there are 2 arrows. So 2 and 3 both are the successors of activity 1. Got it? If I ask you what is the predecessor of activity 6, then there are 2 arrows getting into 6. Therefore, there are 2 predecessors of activity 6. They are activity 4 and activity 5. Now, these are the durations of each activity written at the bottom of each activity number. If I move on this path, that is 6 plus 4, 10 plus 3, 13 plus 1, 14. 14 weeks this path is going to take. And if I calculate this path, lower path, again from start to end, let's go. 6 plus 5, 11, plus 5, 16, plus 1, sorry. No, 6 plus 5 is 11, plus 4 is 15, plus 1 is 16. So the second path takes 16 weeks to complete. Got it? So which is the path of your choice? What path will you choose? Upper or lower? And why? Fatma?
Uh,
You see, when I am comparing more than one paths with each other, there is no competition. Who does it fast? Who does it early? No, it is not a race. Actually, all the 6 activities have to be done in the project. You can't say that I will do path 1 in 14 weeks and my project will be done. Sorry, your project is yet not done because some activities of the second path are yet not complete, and project can only be complete when everything has been done. Got it? Therefore, whichever path is the longer path, or if there are more than two paths, the longest path is called the critical path, because that is the path which, this is the duration which will be required ultimately to complete the project. Got it? Now let's talk about, if I go on the upper path, it takes 14 weeks. But then I have to wait for 2 weeks to get the other path completed. Agree or not? So project will anyways take 16 weeks, and naturally the longest path will determine the size of the critical path. So far, so good. The longest path is the critical path. Do you agree with my justification? Why the longer path is always the critical path? Because it is a condition that all the activities within this project should have been completed. If I go on the fastest path, probably a lot many activities are yet to be done, and project will only wait for them to complete as if the project can be complete. So why not take the longest path? Because nothing takes more time than that. And that is my critical path. Anything else you know about critical path? Any peculiarities of the critical path?
It's
Fatma?
clear.
Yep. Something about why the upper path has got 2 less weeks. Those 2 less weeks, how can they be used?
This is kind of a buffer we have for the project.
It's not called buffer, it's called float or slack.
Exactly.
Some people call it slack. So basically,
float is the way that we call that. Yeah.
On the upper path, we have got a float of 2 weeks. No, actually, they have to wait for 2 more weeks, as if the project can be declared complete. So they will have 2 extra weeks. That is called, they have got 2 weeks float, and that they are comfortable because they know their job can be done in 14 weeks. But if anything gets delayed, they still have 2 weeks to go. They can utilize those 2 weeks, and still the project will not be delayed. So that means the upper path has a float of 2 weeks.
Yeah.
But the lower path has no float whatsoever, because it will take 16 weeks and it requires 16 weeks to complete the project. So there is no float in lower path. So I would say that this is the critical path. Every activity on the critical path is a critical activity. They don't have any float. They cannot be delayed. And I must pay close attention to this path. So what are the critical activities? Activity 1, Activity 3, Activity 5, and Activity 6. Agreed?
Yes.
You will connect from start till finish. Let me connect these for you. For example, I am just marking the critical path. This goes here, this goes here, and this goes here, and this goes here, till the finish point. So all the activities on this red line are critical. So this is critical, this is critical, this is critical, and this is critical. That means these activities have zero float. Zero, 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 zero. They cannot be delayed. Now, what are the remaining activities? 2 and 4. They have an overall float on this path from, let me use another color. Let me use the green one. So from here to here, from here to here, and from here to here, this path is the second path, and that has got total over a float of 2 weeks. So that means activity 2 and activity 4 are non-critical activities, and they both have a collective float of 2 weeks. So collectively, these activities can take, normally they should take 7 weeks, but they could take up to 9 weeks. And still, project will not be delayed. I hope you get the spirit of it. Okay. If that is understood, then we will like to move forward. Let us move on. Okay, schedule presentation formats. It could be a roadmap or what you call a timeline. Schedule could be initially a general, when the business analyst does the business case, he creates a outline roadmap, how this project is going to do what. It could be a timeline, it could be kind of a little bit of a roadmap, but it is not a detailed kind of a plan, a schedule. We won't call it a schedule. But schedule, the initial shape of the schedule could be like a timeline or a roadmap. But actually, when we do the calculations in the project, a project manager does that with his team. They come up with a Gantt chart. You understand what is a Gantt chart? All of you? You could do it by some software, you can do it manually, whatever. And in that Gantt chart, you have a number of milestones mentioned, and you could create a milestone chart separately as well. Although the Gantt chart does include all the activities and all the milestones, but if you don't want to show the activities, you can create a chart of only the milestones shown on a timeline. It could be in shape of a chart, or it should be in shape of a graph. It could be there. And network diagram is the method by which we created the critical path. That diagram is called schedule network diagram, right? And without that, we cannot find the critical path. And once that is done, after doing that, we can develop the Gantt chart. Actually, Gantt chart comes at the end. Roadmap is first. Then is the milestone chart could be mentioned by the business analyst, and it could be considered outline. Milestone chart could be available to create a roadmap. Okay, I agree with that. But a detailed milestone chart will be created after the Gantt chart is developed, and Gantt chart is developed after the schedule network diagram has determined the critical path. Right? After the critical path is known, the Gantt chart is developed, and then the detailed milestone chart is developed. So these are the various formats of schedule presentation. This could be the Gantt chart. You might be aware about it. Like these bars are actually, in project management, we call it the schedule. But the tool we are using, which creates this kind of charts, is called a Gantt chart. These are the activities. This is phase 1. These are the activities we are doing. This is the time each activity is taking. This is the person assigned to this activity. This is the actual progress while the project is functional. The progress, how much progress has been made on each activity or each phase could be written down here. And exact dates when this activity should start and when it will finish is shown on the bar. And this diamond yellow shape thing is our milestone. Right? So in this chart, we have shown you everything. And you can even do the resource allocations. Like you see, Karina Ayang is one of the resources. We need 3 hours of her on this date, 4 hours of her on this date, and so on and so forth. So that way, we can assign the resources and the people and the groups of people in this manner. This could be a milestone chart in which no bars are shown, activities have been removed, only the diamond-shaped milestones are shown here. That is called a milestone chart, a detailed milestone chart, right? This is a traditional schedule network diagram. And on this, we could apply various kinds of relationships. We can use the finish to start, like everything where there is nothing written on the arrow, that is presumed that is finish to start. So this is finish to start, this is finish to start, this is finish to start. Where there is a different kind of a relationship, we will write that with it. This relationship between B and C is a start to start, meaning B should have started as if C can start. What does that mean? H and I relationship, SS plus 10. Who will tell me that?
There's a lack of 10 days.
And can you explain it fully? H and I.
Yeah, the I will start only 10 days after the H activity has started.
Exactly. Very good. So H should have, to start I, H should have started and 10 days should have passed after the start of the H. That is the point when I can start. What is FS plus 15? That is a lag of 15 days on a normal relationship. After the end of F, 15 days must have passed as if the G can be started. And what is between L and J, Fatma? How do you define the relationship between L and J?
L and J.
L and J, this one.
It's FF. It means the task J cannot be finished until L is not finished, is not completed.
Good. Very good. So you got it very closely. Okay. These are the two techniques for resource optimization, although we can discuss them in the chapter of resources, but actually this concept is very closely associated with the schedule, with the tweaking of the schedule, like, we are adjusting things. So let us discuss smoothing and leveling, two resource optimization techniques. How can we optimize our resources? Smoothing adjust the activities within predefined resource limits and within free and total float. So you do understand that there is a float available on the non-critical paths. Agreed? So using that float or consuming that float to take care of certain delays, right? So if an activity on a non-critical path is delayed within the float, it's not a problem for us. So that is somehow we can utilize that float to without affecting the total duration of the project. Now, what we can do is we say, okay, because there is a constraint of the resources, right? I may be employing lot many resources on any one day of the project. So I can't employ so many people in that one day. So if somehow I can, because I have float on this path, I can, delay this activity by reducing the number of people on this task. Previously, there were 6 people on this task. I will put 4 people, and they will naturally take more time. But this, I have got 2 weeks float available. It will take 1 more week without affecting my end date. I will adjust with that anomaly. Like, I have reduced the number of resources and still my project was not affected because I utilized the existing float in that path to meet my ends meet, to make the ends meet. Right? That is it. It does not change the critical path nor delay the completion day. Method may not be able to optimize all resources. Some resources can be optimized, and when we have already consumed all the float, more optimization may not be possible. Leveling is the other technique by which we can do kind of a slashing of resources and adjusting the schedule accordingly. For example, I say that you cannot employ more than 3 carpenters on any one day. That is a rule imposed on you. You say, okay, if that be the case, if you are not allowing me to have more than 3 carpenters a day, but I need 10 carpenters in one day, and on another day I need 6, on another day I need 3, that means if the resources are reduced and naturally it is beyond the limit of smoothing, meaning without affecting the end date or the critical path, it is not possible, then my schedule has to be revised and it has to be stretched. So leveling means that I slash the resources and ultimately my project duration is increased beyond critical path. I hope you understand. So you can read here the last sentence, can change the critical path. So that is a change request actually. That is a permission to be sought because critical path is usually sealed. It is in the baseline. In the scheduled baseline includes the critical path. If you have to change the critical path, if you have to do leveling, you probably have to seek permission and the baseline will have to be changed. How can we compress the schedule? Again, we have got 2 techniques. Those were the resource optimization techniques, smoothing and leveling. These are the schedule compression techniques. One is fast tracking and one is crashing. Fast tracking is very similar to the smoothing thing. What we are doing is we are trying to perform activities in parallel to reduce time. Like, by changing the relationship amongst those 2 activities from finish to start, we are making it start to start or finish to finish, or we are trying to, increase the lead into them. We are giving the overlap. So these are the ways to fast track our project, right? Crashing, when you are in a critical situation where, you have to meet a deadline and you have already been delaying things a lot and you are left with last 3 days and you are determined to complete this in last 3 days, although the work which is still remaining is of 10 days. How can you do 10 days work in 3 days? If you can do it, you still can make the target. So what does that mean? I am going to hire more people, other resources, maybe some machinery or something which can help us do the job faster. So we are trying to meet a deadline of 3 days for the work which requires 10 days or 15 days. So all that measures I take, they will cost me an arm and a leg because that is going to be really very expensive. So crashing will cost more money. But still, we can meet the critical path. I hope you understand the fast tracking and crashing. Once all of this has been done and everything has been properly adjusted, agreed, shown to the bosses have approved it, before the baseline then can be created after the approval of the boss. When there was no baseline established, it was the prerogative of the project manager to experiment with the schedule. He can reduce it, he can increase it, he can tweak it, he can do a lot many things to the schedule until it has been approved by the bosses. If it is approved, now you do not have ball in your court. Ball is now in the court of the boss. If at all you need to change anything, you have to move a change request, seek permission, and if allowed, then you can change come up with a new plan. or a new schedule could be created. And then again, it will have to be vetted by or approved by the bosses. And that would be your rebaselining of the schedule. And that can happen throughout the project many times, but through a very strict change control mechanism. In Agile, we have got some special intervals. We have to actually negotiate how and when they are required. We have to look at the downtime intervals will take place. So naturally, the downtime is time where we are waiting for something to be delivered and we are unable to work anything. We can't work if that source is not available. So that is our downtime. We don't want any kind of downtime in our Agile project. In Agile, downtime is a hurdle, and hurdles are to be removed by the servant leader, which is the team lead, right? So he will always ensure that there is no downtime. All the barriers and hurdles have been removed and team can work smoothly. Then there is a time which is called blackout time. There was one thing, downtime. There is one which is called blackout time. Any idea what is a blackout time? That is a time during which we have completed an iteration. We have presented the user stories to the customer. Customer has approved them. So basically, after the approval, whether it was handed over to the customer or not, that does not matter. As soon as we receive the approval of one of the user stories, the blackout period starts. Because actually, at the end of the iteration, we would be delivering all the outputs of all the iterations we have done so far. At the end of the release, that would be handed over to the customer. So blackout is a time between the acceptance of that at the end of the iteration and the physical possession of that thing by the customer. I mean, when we will ship those items to the customer, in between this is the blackout time. And during this blackout time, customer cannot make any changes because they have already approved it, right? So these requirements which have been completed and approved by the customer, they are not changeable. So we suspend all the changes. Then during this period, there cannot be any change. Reduces the risk as the solution is released to the customer. We have actually shown it to the customer. Customer has approved it. So ball is out of their court. They are in a blackout period. They can't change these requirements. So blackout period is starts after the approval of the acceptance criteria, and it ends after the handing over of those deliverables. So this is the blackout. What is go live? Go live when the project timeline is finished and we have delivered everything. Customer now takes possession of the product of the project, the overall total project. So far, maybe in Agile, they have been receiving continuously small chunks of value. And now is the time when the ultimate total project is completing, project timeline is completed, and now is the time to go live, meaning the people who have asked for it, they will start using it. Okay, then there is a concept of an iteration H, and there is yet another at iteration 0. Just imagine we have our release of say 12 weeks. That means that is how many months? If iteration size is 2 weeks, how many months? 12 weeks. 12 weeks are 6 months, right? So then how many iterations are there in this? 12 iterations.
If it's 12, wait, if it's 12 weeks, then
It's 12,
it's,
no, 12 2-week iterations, right?
oh, okay.
No, sorry. I'm sorry. 6 2-week iterations. 6 2-week iterations total takes 12 weeks. 12 weeks is 3 months, right? So we have 6 iterations. Then we start the uh, first iteration of our release. Before that, we have to plan the whole iteration. How are we going to go about it? So it may be called as a iteration 0 because the first iteration starts. Before the first iteration starts, there is a iteration 0, which is planning of the release. And once all the 6 iterations have been completed, all the 6 iterations have been completed. Now, there are a lot many things which have been accepted in each one of those iterations. Remember, before we hand over or ship the product to the customer, we have to comply with the definition of done. Hardening iteration serves as the last iteration or an additional 7th iteration, you can call it, that will actually sum up the compliance requirements and make them ready for handing over to the customer. You understand what I'm saying? We have 6 iterations actually of work. A 0 iteration is added in the beginning and H iteration is added at the end. This is happening within one release. Iteration 0, iteration 1, 2, 3, 4, 5, 6, and then the iteration H. Iteration H fulfills the definition of done. That is compliance with the all quality standards, environmental standards, this and that. Because before we hand over the things to the customer, they must comply with all those requirements. That is what the definition of done is. But acceptance criteria had been accepted because that was in Agile, that is based on each user story has its own acceptance criteria. At the end of iteration, whatever user stories we have completed and they have been accepted, so they will be considered to be acceptance criteria has been fulfilled for them. They are in the blackout time. And now this is the time after the hardening iteration that we will physically hand over the product to the customer and the blackout time will finish. And if it was the last release and the project has ended, they will go live. The customer will go live on our product. I hope you understand all the points, the downtime, the blackout time, the go live time, and iteration 0, iteration H, and how does it behave in our release. Comfortable with that? Any problems? Good. Okay, schedule management in adaptive environments. Some guidelines are there because in adaptive environment is very different from the way we do it in the predictive environment. So it all depends upon the kind of team composition and the life cycle. In Agile, our team composition is small. We have got 8 to 10 people, and our life cycle is Agile or adaptive. Project team works with the product owner to decide. In the product backlog, new requirements are coming, and project team and the product owner mutually decide which are the tasks you are going to pick for the next iteration. Basically, this is the choice of the project team, but naturally, they have to interact with the product owner and agree with him whether these user stories which we have opted for, they are allowed by the product owner that you can take them away out of the product backlog and get them into your sprint backlog or iteration backlog. That means because those 10 or 15 requirements, user stories, which you have picked from the product backlog, they will no more be available in product backlog. They will now be available in the sprint backlog, and those items which are in sprint backlog cannot be changed even by the customer. Right? So customer can only change the requirements which are still there in the backlog. They can add new, they can amend the previous ones, they can do it. They are free to do it. But we have put a restriction that when we start an iteration, all the work we have taken in our sprint backlog, our iteration backlog, will not be challenged until acceptance by the customer. So you choose approach. There could be two approaches. We could have a time box schedule with backlogs. So like, time box scheduling is that we have got iterations. Every iteration has got a specific time period, 2 weeks, say, and we have got a backlog in the product backlog from where we are taking things, getting them into the iteration, and then within the iteration, we develop our own schedule for doing what we are doing. Methods could be different. We may not be using Gantt chart or critical path here, but the scheduling of the iterative project or agile project is happening within the iteration. And then we have got another way of doing it, that is on-demand continuous scheduling. In this method, this is a lean method, or we call it a Kanban method. It does not classically have the iterations. All the work is lying in the backlog, and we, as on required basis, we keep picking up the highest priority items directly from the backlog and keep doing them. Not in an iteration, but in a mechanism where I explained to you that the to-do list, to-do is the first column, middle column is work in progress, and third column is done. What we do is, rather than having iteration, we put a limit to the work in progress that at any one point in time, we will not be dealing with more than 3 user stories at a time. That is the decision of the team. So, when we start the work, out of the to-do list, we will pick up 3 items, put them in the work in progress. Now, because the limit of 3 has been achieved, so we cannot add the 4th one. As soon as one of these 3 tasks is completed and moves to the done column, we have a space created for one more task, and therefore maybe we pull the task number 4 into that into our work in progress, and we keep doing that. So if you look at it closely, we in on-demand continuous scheduling, we don't have iterations. And then Kanban method has been created with agile, it's combination of agile in such a manner that it is lean as well as agile. So what we do is, although we have iterations, but we also have work in progress applied within the iteration. It is not for the whole project, but within the iteration, we have a WIP applied. So we take the advantage of lean as well as of agile. So that is what is the most ideal method. Project team selects activities for delivery within an iteration or sprint, and teams produce increments of value for delivery and feedback. And that goes on a continuous basis. This happens in agile and hybrid projects. Predictive, we have already discussed. So in adaptive scheduling, on demand, which is Kanban or lean based, we allow individual requests to be addressed, levels out work of team members, best when activities are divided equally, right? does not work well in a project with complex dependency relationship. So if the matter is simple, probably on demand can be used. But if it is not simple, better go for time boxing. So here we prioritize requests to determine start sequence, then sequence stories individually through completion. Team pulls work from queue. We pull as soon as we have done one of the three jobs we are doing, we will, one job is completed, move to the done. So a space is created, we pull one new job from the product backlog directly. So that is what is on demand. And provide incremental business value. So continuously we are delivering value. As soon as something is done, it is handed over to the customer, right? Time boxed and iterative, this is the same thing which we have been talking in Agile. We have got iterations, we have got progressive elaboration happening here. We use a specific work interval that maybe our time boxing is 2 weeks, allows changes at any time. Naturally, the product backlog can be changed anytime. Even in Kanban, the product backlog can be changed anytime. Define requirements with user stories, then prioritize stories. Select work based on priority and time box, and remaining stories to the backlog. Reintroduce stories later based on priority, and deliver business value early and incrementally. So I have told you both the methods, the on-demand lean method and the time box purely agile method, right? But Kanban is also considered as a agile method nowadays. This is how your adaptive planning is happening. You have got your project divided into certain releases, just like your predictive project was divided into phases. Here we have releases. So after the product vision has been created, product roadmap is developed, that these are the releases, and at these release points, these are the things we will be delivering to the customer. This is the output of that. Then we develop a release plan in which we identify the size of each iteration, and naturally, whatever we decide the size of iteration will be, would be repeated without any change. If 2 weeks, all the iterations will always remain to be 2 weeks. So we say, okay, in release 1, we will have these many iterations, and naturally, at the beginning, in the start, there is a iteration 0, and at the end, there is a iteration H, right? Within every iteration, we have got certain user stories representing certain features and requirements. All the user stories are broken down into tasks, and the story point is their estimation. How level of difficulty of this task is how much. This is represented by the story point, and that's how we keep doing these jobs. So when all the work is completed, all the user stories will be completed, and those user stories which are acceptable to the customer, they will accept it. Others will be rejected, or any undone work will also be put back into the backlog. Scheduling aligned to features ensures associated work is coordinated. So if there is one feature which is too complicated, and we have broken it down into 3 user stories, so that means when those 3 user stories will be accomplished, this feature would have been completed. So associating features with a product roadmap offers visibility, and when blocks of functionality can be released to the business and the end user. This is your agile release plan. You see, actually, like in a critical path, you said everything was connected. Here in agile, everything is not connected, but some of the things may be connected. For example, we have this requirement on top priority. But to reach this requirement, to complete this requirement, I have to, complete all of these things before that. So there might be some sequence existing somewhere. Otherwise, all other user stories shown in yellow and blue, they are like, these yellows are the stories, and these stories are not connected with a sequence, but they are connected on priority, right? So basically, these are first priority jobs, then second, third, fourth, fifth, sixth, and seventh, right? This is all. This could be mapped. This is called a story mapping. Measure effort, not time. As I have mentioned to you earlier, the estimation in Agile is greatly, approximation. We don't go for exact figures. We don't need to. When we can do the job with approximation, then why to waste time in a lot of detailed calculations? So how do we do the estimation? Like we use one method which is called relative sizing. Like, it is also called t-shirt sizing. Like we have got various sizes in t-shirts, like extra small, small, medium, large, extra large. So you can classify that, okay, this story which is coming up, should it be graded extra small, small, medium, large, or extra large? So that will help you prioritize those stories in certain categories. So maybe extra large is the highest priority. So we will start doing things from extra large. And then when all the extra large works have been done, then we'll move on to the large and so on and so forth. Second method is allocating story points to each user story based on its level of difficulty and maybe complexity in that activity. Are more complex or difficult user stories could be assigned larger number of story points, or if it is simple, maybe a very small number could be allocated to it. So story pointing can also be done through a technique which is called Fibonacci number or sequence. What is a Fibonacci sequence? Anyone? Can you see the diagram of the spiral on the right-hand side? Basically, this is the Fibonacci spiral, and this was a great invention. Rather, I would not call it an invention. It is more of a discovery. Because in nature, everything is in a spiral. The galaxy move in a spiral. Water revolves in the sea in a spiral. And a lot many things are in a spiral. And the formula for spiral or the sequence is that every next number is the sum of the previous two numbers. For example, you have got 1 and 2. The next number will be 1 plus 2, 3. Right? What will be the next number? Last two numbers were 3 and 2. 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, 13. So these numbers which I am speaking, these numbers are the sequence of Fibonacci. And if you can somehow draw it, it will form the shape of this spiral. This is one method. Planning poker. Like we use Fibonacci number in that. What we do is we print out the Fibonacci numbers on playing cards. Like playing cards kind of a deck is there with every team member. Maybe you have got 20 cards in each deck, and those cards have numbers 1, 2, 3, 1, 2, 3, 5, 8, 13, and so on. So say 20 numbers are there in the deck. There are 20 cards, and everyone, all the team members have this deck. Now I ask them, as a team lead, I ask them, how do you estimate this story? According to the Fibonacci sequence. So whatever they think, they will pull out a card which they think represent to the level of difficulty of that activity. that user story. So they will display that card to the facilitator, to the team lead. So somebody has brought out a card of 13, somebody has got the card of 8, and somebody has got a card of 1, somebody has got even larger card. But most of the people would be of a similar opinion. We have learned from the standard deviation that when we take opinion from many people, most of the people have almost similar opinion. So in planning poker, we see that most of the people are saying that this story should be something like 8, but one person is saying it should be 13. So then they start explaining to the other person, it's like convincing. Why do you think that this number 13 you have chosen is most suitable? The optimist and the pessimist, they give their opinion and then the voting is done again. People change their opinion. Ultimately, they gain the consensus after a number of cycles, and that's how planning poker helps us estimate the user stories. I've already told you what is the definition of done. That definition of done in the bottom, it says, describes the goal or desired state. It must be informed by the DOR. Now, DOR is definition of ready. Before you mobilize your resources to do your work in an iteration, you must have completed the definition of ready. All the preparation should have been initiated. Now you are almost ready to start the work. And while the DOR is created, the DOD is defined in that. What will be accomplished? What will be the acceptance? That is my definition of done. Maybe that includes some compliance requirement like quality, environment, and all. So because before handing over anything to the customer, we want to be safe and that everything which passes through should adhere to the definition of done. That means not only the acceptance criteria, but in addition to that, all the other compliance requirements, like I said, quality policy of the organization and things like that. So this is how I define the DOR and DOD. These are the iterations which we have, we did the sprint planning, did the iteration, did the got the feedback, backlog prioritization is done after the iteration, and then new sprint is being planned. Then the next iteration starts, and this goes on and on. Hybrid scheduling model. Naturally, we already do understand what the hybrid would be like. Identify project work types and try to break them down. Create a prioritized work backlog which fulfills the project phase or achieves milestone. Work in iterations. Lower level, we work in iterations or sprints. Plan work before every iteration using prioritized backlog. So this prioritization of backlog is considered our planning. Estimate every task to decide how many can fit in a single sprint. Hold a retrospective at the end, we know that. Capture metrics to adjust timing and task estimate. That is a retrospective where we learn lesson and apply it immediately in the next sprint iteration.
Suhail, that
Yes.
looks as an adaptive project scheduling.
Well, this is
where we can see that there's component from the predictive type of project.
actually on the top is the predictive method. A hybrid is a combination of predictive and that. So the top people, the project manager, the sponsor, they're creating a project plan, they're doing everything. And they have created an outline schedule at that level. But then lower down, we are behaving exactly like Agile, right? So because it is partially predictive and partially hybrid, so we are calling partially Agile, so we are calling it a hybrid scheduling model. Okay, questions? The project manager informs the project sponsor that the project management plan will continuously increase in the level of detail as the project moves forward. The project management, what is this process known as? Life cycle, progressive elaboration, resource planning, or scope creep?
Progressive elaboration.
Okay, everybody thinks so? Great. A business is unclear on the direction and when features are to be expected for an agile managed project. What project artifact helps communicate the goals, milestones, and potential deliverables, releases, or other project outputs? So tell me, what project artifact helps communicate these things? Is it a product roadmap? Is it a project charter? Is it the requirement document? Or it is the configuration management plan?
Product roadmap.
Product roadmap. Okay, you're right. You're right. Which is the best elicitation technique to use when your project team wants to facilitate a discussion with a certain set of users to get a better understanding on how they might use your project's product? Is it document analysis?
Focus group. I think we did these questions yesterday.
Okay. If they're repeated, okay, tell me. So we did that also. That.
We didn't do
This one?
no, we did that one. We just hadn't gone over planning poker yet. But yeah, we did that one.
Okay, your company designing
We did
a
this
game.
one also.
We did this one also. Okay, then I think we have done all of these. This one.
We haven't done these, no.
Okay, let me see. This one.
We haven't done that one.
Which of the following is the correct definition of the critical path? The correct is the last one, as you can see. The critical path is the longest path through the network diagram. Got it? Which represents the earliest the project can be completed. But I mean, this is the minimum duration required to complete the project. If the critical path is 16 weeks, then we cannot complete the project earlier than 16 weeks. So earliest this project can be done is in 16 weeks. So in a way, I can say, although it is the longest path, but this is the shortest possible time in which this project can be done. Got it? Okay. How should the project reply? Okay, statement. If we must complete the software code before we can create the user manual, what type of dependency exists between the two work packages? Complete the software code
To start.
before. Finish to start, right? Which of the following is not a technique for estimation? Planning poker, t-shirt sizing, product box, and modified Fibonacci.
Product box?
Yes, product box is a different thing. It is not for estimation purposes. This is for experimentation. Rather, it is for collecting the requirement, where we ask the customer to try to, whatever they want us to make, assume that this thing is already there and you are trying to sell it to us. How would you sell it? So the requirements which are not clear can be clarified in this marketing exercise, selling exercise. Which of the following is the best approach for estimating effort? Project manager estimates all the work. Team lead estimate all the work. Work is estimated by the people who will be asked to do the work. Estimates are inflated to avoid second guessing from the customer. Yes, Kelvin?
Yes. Option C. The people
C.
who will do the work is the best one
Okay,
to
good
provide the
enough.
input.
So that brings us to the end of this chapter. Although I was expecting that I could start the next chapter today, but we are done with the time. Rather, we are overshot the time a bit. But naturally, we are done so far. I will try my level best that in the next two classes we can cover as much as we can. If not, then I'll give you more time, but I will be busy from next Monday onwards. So maybe we have to select another time or something like that, right? So probably we can do that, but I assure you that I will get you through all of the lessons, right? So let's do it for next 2 days and see how far can we go, and then what could be our next schedule. Is it okay with you? Yes, Kelvin?
We have lesson 4 and 5 and 6. Oh, no.
Actually, this is the longer one because this is all about planning. A huge, huge chapter. Although we have done the major part of it, but still we are on 4. Yeah, this is 3.
Okay.
We're still on 3. So we have to start 4, 5, and 6. 6 is very small. 4 and 5, we need 2 sessions. And I
Oh, we
suppose,
are doing, we are applying the crashing technique.
yeah. Actually, I wanted to complete this chapter today, but naturally, if it takes one day tomorrow and I can complete it, then chapter 5 I can do in another session. Chapter 6, uh, probably we have to schedule for another one. 5 and 6, probably we have to do something about them. One day required for that.
Okay.
Okay, let's see what happens. So let's continue till day after tomorrow, and then we will decide on the last day what is our plan, right?
Okay.
Okay. Maybe can we do less examples throughout when we go through the lessons? Can we do just I think we spend a lot of time on things with examples, which is really helpful. But since we're crashing, as Kelvin said, if we could do less examples and just kind of keep going through the material, that would be helpful for me.
Yeah, actually, you have all the slides, don't you?
Yes, we do.
So that would be very good if you can go through the remaining slides and just tell me what you don't understand, and I will jump to those slides, and we can be very fast. We can talk about examples, we can debate on certain things, but things you already understand, we should not waste time on that. You understand that?
Okay. I don't really have a lot of time to go through all of the additional
No,
material before
not all,
tomorrow's class.
not all of that, not all of that. For example, the remaining portion of today's lecture, you can go through that before the next class tomorrow, right? Just scan through that and tell me that these slides you understand, these slides you don't understand. Where there will be an agreement that these slides need further explanation, I will explain that. Otherwise, I don't want to miss out anything. I will probably, even today, I didn't skip any slide at all. I did explain everything, right? But I am requesting you that if you think, all of you three think that this is, we know, we don't want to talk about it, then I can skip that, right? Anyways, we will continue the discussion tomorrow and day after, and then we decide what will we do for maybe another 3 or 6 more hours. 6 hours, I think we need more.
Okay.
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 Thank you very much and take care. Bye.
Thank you.